Today, we will be presenting about the smart streetlight system as a remedy to the high electricity consumption of available streetlights. The members who contributed to this project are Ravindu, Derek, Hashini, Anupa, and me, Bashita. The key problem of the available streetlights is that due to the inefficiency of their working system, a vast amount of electricity wastage is taken place. As a result of their manual operating system, they are kept switched on all night, even when no one is on the road. Also, due to carelessness, they are kept switched on in the daytime too. We need a new solution in order to overcome the issue of high electricity consumption, which results in high expenditure and energy wastage. Due to the need of manual operation, it is hard to operate streetlights during severe weather conditions like heavy rainfall. Hence, a highly efficient and cost-beneficial solution with an automated working process is required as a solution. As a result of streetlights being switched on all night, frequent breakdowns take place. This has caused to create traffic accidents due to less light intensity in the road. This bar graph represents a research done in India, which shows the severity of accidents with and without street lighting. Environmental analysts have proved that street lamps contribute to light pollution as a result of direct glare and reflected light. These affect animal biological activities as well as creating human health issues like sleep disorders and headaches. So, we will be providing a smart solution which will have an automated working process that will ultimately conserve energy and reduce costs. Our product will not require human labor for operation and will ensure that it will result in minimum environmental impact.
This is the conceptual design of our product. The reason we chose this design was to minimize energy consumption. The lighting is placed at a height of 10 meters from the ground level, while the circuit box is placed 7.5 meters above the ground level. Let's have a closer look now. As you can see, the supporting arm is 1.5 meters in length. The position of the sensor box and the circuit box can also be observed. The LDR is placed on the sensor box to identify day and night conditions. These are the three main components used in our lighting system. Now let's talk about the principles, embodiments, and materials used. The sensor uses the principle of the Doppler effect. It can detect vehicles and pedestrians based on the time taken for an emitted wave to reflect and reach the sensor again. The material used here is high-impact ABS plastic enclosure. We will be using a 180-degree motion detector with a range of 60 meters. Inside the circuit box, the relay module amplifies the voltage and supplies current to the LED. The material used here is aluminum. In the LED, light is produced due to the recombination of electrons and holes. This is based on the principle of electroluminescence. We propose using an LED with a beam angle of 180 by 150 degrees. Now let's consider the functional decomposition and energy transfer of our product. In the sensor, emission of the light rays and detection of the reflected rays takes place. Then it converts the incoming signal to a binary signal. The main function of the sensor is detecting human and vehicle motion at the required distance. The function of the circuit is keeping the light activated for the required time. It converts binary signals into an electric pulse. The LED converts electrical energy to light energy. Its main function is providing appropriate lighting conditions. Next, you will be able to see how this design works.
Here is a typical streetlight you can see beside roads with a manual operating system. The sky is already dark, and a man walks on the pavement and stops by to switch on the light. You can see the light can only be activated by such human interference. There are hundreds of such streetlights in a road to be activated. So, is this process efficient? Think to yourself. By this time, most people are in their houses enjoying their dinner. With the time closing to midnight, most streets of urban and suburban areas become lonely. By this time, density of vehicles in the street is very low, but the light is kept switched on continuously, even no one uses it other than ghosts. The night passes by in the same way. Here comes the morning sunshine, giving a start to a fresh and a brand new day. The street lamp is still switched on. A busy man walks past the street light without switching it off. Most probably, with the bright sunlight, he may have not noticed that the light is still on. This is what practically happens. No one cares to switch it off, even they activate it in the dark. Here comes our product. The switch is removed as it has an automated working system. As you can see, the circuit box with the relevant components and the motion sensor, which is used for detection, is fixed to the light pole at the required height. The power-consuming compact fluorescent lamp is replaced by an eco-friendly LED bulb. The dark rolls again. This time, with the proper detection of the human motion, the streetlight gets activated. As the person leaves the detecting range, the light will switch off after a set time period. Here comes a motor car. As you can see, at the relevant distance, the sensor detects the motion and activates the system. As a result, the system will only get activated in the presence of motion. This cut off the unnecessary time the light kept switched on while saving electricity. In the daylight, the whole system is under a shutdown condition. Even the man walks, the system does not light up. In result, this will save more energy.